We live? We're live. Cool. All right. Okay. So, we are on day 3 of working on a version of Breakout for the Game Boy. So far, we've got the system set up. That's what we kind of did the first day. On the second day, we started getting a ball on screen and moving around. And we got a little caught up in trying to do the physics of the ball. It was a really good reminder for me that trying to do any sort of math on the Game Boy's processor that isn't just basically adding two 8-bit signed numbers together is an enormous pain. Originally, I was hoping, I'm going to scroll up and show you this. Originally, I was hoping to use 1 byte for the ball velocity in each direction. So the basic idea is that we don't want to just store the pixel location of the ball. We want to have a little bit more precision than that. We want to be able to store subpixels like a pixel and a half or whatever. And this allows us to have like more precise, more sort of subtle physics. It allows us to have like the ball move a pixel and a half every frame, for example, rather than just going from 1 pixel to 2 pixels every frame to speed it up. You end up getting a lot less precision. And so I was going to store the ball position would be 8 bits of the pixel, and then another 8 bits of subpixel. So each subpixel would be 1/256th of a pixel. And that would get us like a fair amount of precision. But then for the ball velocity, I was originally thinking, well, I don't know if I want to use 2 whole bytes for that, because it's not like the velocity is how much the ball moves in any given direction every frame, and it's not like the ball is going to be moving a lot every frame. And so not only would using the same format for the ball velocity as I was using for the ball position be kind of like a waste of memory, which is pretty limited on the Game Boy. It also, very often I found when trying to do 16-bit math, you want to avoid doing full 16-bit math if you can on the Game Boy, because it's slow and there isn't a ton of CPU support for it. It's an 8-bit processor. Now, that being said, I spent some time after the stream yesterday kind of reflecting on it. And the Game Boy does have some very limited 16-bit support. You can like load a 16-bit constant into a register pair. So you can pair these 8-bit registers and you can load a 16-bit constant into one of them. It does have very, very basic. It has support for addition, incrementing, decrementing these 16-bit register pairs. And I sort of thought, well, you know, in this case, actually maybe the right thing to do is to just use the same format for the ball velocity as we're using for the position, and just use the 16-bit adding. And it's like not ideal. It's slow to load these registers, but given that we're trying to do signed arithmetic, And trying to do some fixed. I was trying to do like fixed point stuff. I was trying to store the ball velocity basically as four bits for pixels, and then 4 bits for the subpixels. You know, it was trying to do signed arithmetic with that, and there's no sign extension support of any kind on the Game Boy CPU. Like, I just think that maybe this is going to work a little bit better. So I'm going to give this a try. We're going to see how it goes. You know, I haven't planned any of this in advance, and I have implemented sort of this kind of physics engine before on the Game Boy. The code for that was kind of nasty when I was basically doing what I was trying to do in the last stream with the fixed point 8-bit velocities with 16-bit positions. I've done that before. The code always ends up being kind of nasty and unpleasant. So I'm going to try this instead, and we're going to see how it goes. And I'm kind of optimistic that it's going to turn out a little bit better. So I don't know, we'll see. So let's get going. We're just going to go here into a knit ball. And I'm just going to basically do the same thing. I'm going to set the velocity to 1.5 pixels. So we're going to get the position, ball velocity, or the velocity. We're going to get a pointer to it. It's going to be the subpixels first. So that is going to be half a pixel. That's 128 subpixels, which will be half a pixel. We're going to load that in. And then we'll do the same thing for the y velocity. Yeah, yesterday when I sort of what I was doing before when I was trying to do yesterday it didn't work. Like there were some obvious bugs that I found when looking over the code after the stream. I wasn't handling sign extension properly. There was just some bugs, like wrong constants being used and stuff. But I think at the end of the day, this might just turn out to be a little bit nicer. Okay, so yeah, and we're going to be able to get rid of like a bunch of this code. It's still going to be weird. So what I'm going to do is I'm going to first get the ball velocity x. We're going to load that into BC. Do I want the ball velocity in there, or do I want the... Well, we'll see. And then we're going to get the actual ball position. It's a little bit nicer because it'll be consistent. We're going to get the actual ball position. Okay, so now HL is the ball x, BC is the velocity, and then we just do add HL to BC. So now HL should now contain the new updated position. There we go. And that's just hopefully kind of it, you know? Now, of course, we still need to do the collision detection, unfortunately. But we'll just do that. I'm honestly just going to delete all this. Actually, I'm going to... take all this and put this out into its own procedure. And then we can actually just, you know, maybe it would be nice to use a macro for this or something like that. But so we don't have to duplicate all this code and copy and paste and everything, but whatever. And this should still be the same. Okay, so I'm going to build that. Oh, and we got a syntax error. Yeah, okay. I'm going to list a couple inserts here. Okay, that seems to work. Pop open our emulator. See how it goes. Interesting. Very interesting. Why is it doing that? Oh. Well, I don't think that would be why, but oh, that's why. Because we're not actually building a new version of it. That's what we were getting yesterday. Because we can't do that. Okay. Now 166, we got this right. We have the same error. Wonder if it'd be faster to copy. Yeah, it's so easy to get caught up in like trying to micro optimize everything. Not a great. There we go. Okay, we're built. Reload ROM, run, see what happens. Hey, it works. Looks great. And now we're moving at 1.5 pixels a second. So that's great. The only thing I'm curious about is micro optimize it a tiny little bit here. So what I'm going to do is I'm going to take the new ball exposition and I'm going to put it in AB. So then we can do this, which is quite a bit faster actually. That's quite a bit nicer. Yeah, look at that. Those are the joys of assembly language programming, like micro-optimizing a couple of cycles by being like slightly clever with your limited instruction set. Everything's like a puzzle. It's like, you know, it's what's fun about it. It's like solving a puzzle. Okay. And to rebuild, I don't know. Like, of course, it doesn't really matter, probably, but just the satisfaction of writing tighter code is, like, kind of fun in and of itself. All right, so actually, yeah, that worked really nicely. Now, we can start trying to do some collision detection. And so what that is going to entail, probably, well, let me see. Let's try to save the work. Let's save the work we just did, because I believe the last time, yeah, let's actually, what was the last log? Okay. Okay. So now what we want to do is we're going to want to do the collision detection here. The collision detection here is if we hit the right side, we need to do two things. First of all, we need to push the ball back into the playing field so that it's no longer out of bounds. And then we need to reverse the velocity in the x direction so that we're bounced backwards. So first we're going to test the pixels. And we're going to compare it to 160. And I explained this yesterday, but I'll do it again. Comparison does a subtraction and sets the flags in accordance with the subtraction without actually writing the result of the subtraction back to the accumulator. So if our current position is 159, which is inbounds, the screen is 160 pixels across. That's going to equal -1, and that's going to set the carry flag because we've gone from 0 around to -1. Whereas if we're at 160 or 161, we're not going to go into the negatives. We're not going to set the carry flag. So basically, we load A with H. We compare it to 160. If the carry flag was set, that means that we are less than 160, and we're just good to go. And we just keep doing what we were doing. But if we wrapped, what we need to do is we need to we're going to need to do two things. First of all, we're going to need to set the new position to just inside the screen. So that's going to be and we're writing the ball x value back. So we're going to just put this into HL so that way that we can reuse the same write back logic. So we're going to load H. This is the pixel value. With 1 to 59. And we're going to load L. This is the subpixel value with FF. So that is 256 of a of a pixel. So that's just, it's like 159.999 or whatever. That's going to be the new position, and we're going to get to keep using the same write back logic. And then the other thing we need to do is we need to negate the ball velocity. So we have to do a 16-bit negation. So that's going to be, I think it should be pretty straightforward. The subpixels, we do a full proper negation. The choose complement negation is you invert all the bits and then you add 1. Because, and again, I explained this yesterday, but let's go over it briefly. With choose complement, it sort of comes from the intuition that you want to wrap around by subtracting 1 from 0. And when you use like a standard unsigned subtraction, well, you wrap around, and so you end up with FF. So we want to, FF is -1. So if you compare 1, which is that in binary, to FF, which is that in binary, what we've done is we've inverted all the bits first. So if we invert all the bits of 1, we do that, and then we add 1 to get the thing. So because the pixels are the most significant byte, all we're going to, because the subpixels are the least significant byte, they're what we load first. So we're going to get those and we're going to do that negation. So we first get the complement to invert all the bits, and then we add 1 to we increment it to add 1, and then we're going to write that back. And then we're going to get the most significant byte. In this case, all we have to do is get the complement, and then write it back. So I'm just going to... collision. Okay. And then there we go. And then we write back the new X position, which is located in HL. So I think that's all correct. Let's find out. Builds. We're going to reload the ROM. We're going to hit run, and we're going to see what happens. Yeah, look at that. Of course, we don't have any collision on the left side yet. We're going to need to do that. So what's happening is we're bouncing off the right side and then just continuously wrapping around on the left. But that looks like it worked, and that was not bad at all. I'm actually really happy with how that turned out. So hide that so we don't have the distracting ball bouncing back and forth. This procedure is starting to get a little bit unwieldy. Let's see how it goes. If there's anything we can do to clean it up. I might actually be able to just. Let me put that in a separate procedure, because we're going to need to use that on the right as well. So having it in a separate procedure is a good call. In terms of reuse. Boy, I need to adjust my tabs in this. I don't want 8-character tabs. That's terrible. Okay. So now let's do the left side collision up here. So when are we going to get left side collision? I believe we're going to get left side collision just when this wraps around, when we go less than 0. I'm crossing my fingers that that's correct. Because I'm trying to think, is there any other, like we're never going to wrap around on the right because we're always bouncing off. So we're only going to wrap around, we're bouncing off way earlier. So but the ball position is actually right, because we do actually allow the ball to I'm just pulling up the OAM for reference. So the X position on the Game Boy, the sprite's horizontal position is subtracted by 8, which lets you have sprites that sort of go off screen a little bit. So because of that, we actually don't want it to wait until we go under 0 to bounce, because we want it to bounce when we're at the left side of the screen, which is actually X position 8. So what we can just do is check to see if we're under 8, and if we're under 8, then we've collided. Okay, so that's good. Yeah, okay, that'll work. We're going to compare A to 8. I think 8, let's see. So suppose A is 7. This is, if A equals 7, we want to bounce back. So 7 minus 8, 7 minus 8, so that's the carry flag. Yeah, so we just want to do it if there's no carry, because if it's 0, we don't want to bounce. Maybe we want to bounce when it's 0, but I don't know. We'll see. So we're going to compare to 8, and if there's no carry, there's no carry. And I'm just going to, there might be a way to consolidate this logic, but and then let's just jump, and then we're just gonna go over to the right back, and there we go. And I think that'll work. I think that's everything. Oh yeah, I gotta update this. Okay, so I think that should work. Let's reload the ROM and find out. Yeah, look at that. Look at that. Beautiful. Oh, that worked so nicely. There we go. So now, unfortunately, we are going to need to do some copying and pasting. If you are a programmer accustomed to high-level languages, you might wonder why I'm not using more functions. I was going to say, but I will actually use a function for this. But in general, it's like very unpleasant to use functions. Like in which you pass things and return things when you're working in such a primitive assembly language, just because there's like so few registers to pass arguments around in. Like stack operations are brutally slow. Like generally hard coding things works a whole lot nicer, unfortunately. But this, you know, like where you can use some kind of functions and it like works okay, that's awesome. But I often prefer to just hard code things, if I'm being honest with you. Even if it means code duplication, you can get around that with macros sometimes. But this is like a good candidate for it because like the code is very, very similar except for one thing, which you're just putting in the register immediately. So it's probably fine. Like I almost never bothered using like a general purpose copy routine. I just like add a copy loop wherever I need it. Right. Okay. So we're gonna just do the same thing for y now, and like this is gonna be good because eventually the logic for like x and y are going to be using slightly different logics because the screen is like a different size and I don't want to start like I don't have a good way to like pass arguments in and stuff and like store them and like get them back and we're gonna eventually we're gonna get rid of the collision on the bottom of the screen because of and you can see like the Y position is 16 rather than 8. And this is 144 instead of 160. And we're going to get rid of the collision on the bottom of the screen because, or it's going to function differently because it's going to cause you to like lose a life or whatever rather than just bouncing. So it's unfortunate that we have all this code duplication, but it's kind of just a fact of life. I don't know. That's what I have to say about that. I've rambled enough about that. Does it build? It builds. Does it work? It works. It looks pretty good, although you'll notice that we're bouncing a little too early on the bottom and also on, it actually looks really close. Oh, on the right it's actually okay because, oh yeah, on the right it's okay because we get the right side of it. But on the bottom we're bouncing too early. So for what it's worth, let's fix that. That's because the Y position is offset by 16 because of the way the Game Boy Spray hardware works. So we actually want this to collide a little bit further down. Just another 8 pixels down, I believe should be correct to account for that and also the height of the ball. Yeah, that looks right. There we go. We got a ball bouncing with sub-pixel motion, all 4 corners of the screen. Looking great, fairly straightforward code. Very pleased with this. Let's save that. Let's do a git commit for that. What was the last version of this that I committed? I guess it had. Okay, yeah. So there we go. Cool. All right. Yeah. Now the next thing I want to do is I want to add the paddle, the player's paddle. So I'm going to rename this to spread data. And let's see. I'm again just going to sort of draw out some kind of like rough shape. Just using hard-coded constants. And this should be even easier than the ball, honestly, because it's kind of going to be like a rectangle. And in a more sophisticated game, we'd, maybe put these in different sections or whatever so we could load them dynamically as is appropriate. But we're always going to have the ball on the screen. We're always going to have the paddle on the screen. Let's just load them all together. See how it goes. Yeah. Paddle. And this is going to be really, really similar to the ball code, except that I don't think we even really need to, at least right now, we don't need to have any sort of Y stuff. Because the paddle is always at a fixed Y location, right? So and also we're going to start with the paddle not moving at all. We're going to instead of having it move on its own, it's going to be under player control. So yeah, basically the same, except we're setting the velocity to 0. And I'm just going to keep using the same logic because that was so successful. I think that's my new preferred approach for dealing with physics, honestly, on the Game Boy. So for update paddle, right now I'm just going to stub it out because this is what's going to start listening to player input and move the paddle appropriately. And I'll worry about that after I get the paddle up on screen. And the paddle OEM is going to be slightly more sophisticated. I'm going to make the paddle 16 pixels across. So we start at the Y position, and that's just going to be a constant here. And then we're going to load that in. Okay. And then we are going to use, well, actually, we're not here, but we will. We're going to use 2 sprays for it. So the second spread is going to be the right-hand side of the paddle. And we're going to, so we take the X position, we add 8 to it. Oh my gosh. And then we're going to write that in. And then we're going to skip. Oh, and actually we do need, yeah, that's so we didn't write in the tile number because the ball is tile 0. So for now that's fine. That's probably fine for the ball. For this, we do need to use this constant. And I mean, I could write this in once and then never again, instead of writing it in every frame. Same with the paddle Y, but it's probably easier to just do it every frame in one place. And like, as your games get more sophisticated, you'll need to do more stuff like that every frame instead of just writing stuff in from the jump. So might as well just keep this pattern. So we're going to use the same tile for the right-hand side, but we're going to flip it. That's right? That's right. Okay, we're going to flip it. So that it's got like this nice mirrored look. That's okay. Okay, cool. So that's all set up. And now I'll just need to define those constants. I'm trying to think. I believe the syntax for that is like that. What's a good Y number for it? I don't know. Whatever. And then the paddle tile is 1. Does that build? Do I have a syntax error? I don't have a syntax error, but I do have an error because when I was copying and pasting, I forgot to rename things. Let's see. Now, does this work? Yeah, there we go. And there's our paddle. And it looks great. Of course, there's no collision with it yet. And there is there's no collision with it yet, and you can't move it around, but we've got a paddle on the screen. So that's progress. And that's really what it's all about, just like tiny little bits and pieces of progress. Until eventually you've got a game going. So next, we need to update the paddle. And to do that, we need to read input. And the thing to do is to read input once per frame and save it, rather than, because reading input is actually slow and kind of unpleasant. as you can see, like you need to um, write to the register to specify whether you want to be reading buttons or directions. And then you need to read it in, and then depending on exactly what you want to do, um, I like to do things like allocate use a single byte for both the buttons and the directions, and so that involves doing a little bit of bit manipulation work. And I also like to do things like store the input from the previous frame, so that when you press a button, you can detect whether the button was just pressed or whether it's been held down. So we're going to read the input in a completely separate part of the game loop, and then just constantly, and then just refer back to that variable. Oh, and also 0 is pressed rather than 1, which is very confusing, and I dislike that as well. So I also like to invert the inputs if I can. I'm going to start with this, though. So so FF00 is the joypad input. So I'm going to do a few things. I am going to set C to 0, and that lets us use this particular instruction. That lets us read from high RAM, basically FF00 quickly. And then, as it says, you read from it repeatedly several times to allow the inputs to stabilize. Honestly, I could have sworn like maybe some older version of the Pandocs actually had the code for this, which indicated exactly how many times you should do that. I'm just going to say 8. Let's do it 8 times. So first, we're going to write to the register. We're gonna read the gosh, I wish they had like an example of this. Sheesh. Because it's weird, right? Like you select it by setting it to 0. I just don't have all this committed to memory. I feel kind of sketchy about this. So in this case, let's do it this way. So this selects directions, and then we're going to write to it, and then we're going to read from it, let's say 8 times. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and now we're going to assume that this is correct. What I'm going to do is I'm actually just going to write that into B for now. And then I'm going to write to it. And even though we're not using buttons right at this moment, I think like having like a nice general purpose input system is like a good call. So we might as well. Like we're going to need buttons eventually, even if just for stuff like the title screen. So, and then we're going to do the same thing. And then I'm going to get the input into like a nice format that I like. So what I'm going to do is I'm going to OR it with B. Or no, I'm not going to OR it with B yet. First, I'm going to swap it. So that way, these 3 bits are now put in the top, or these 4 bits, sorry, now put in the top 4 bits. Then I'm going to OR it with B. These are buttons. And so now we have we've got our input as desired. We've combined the directions of the buttons, and then, as I said, I sort of maybe not. Sort of thinking maybe I should invert it because it's like makes more sense for the bit to be on. But I guess it doesn't matter. Like, why waste the instruction? The bit to be on when the input is pressed down. But, you know, why waste the instruction? So now we're gonna store that. So the directions are gonna go up on the top, and the and I'm just gonna make note of this here. Oh, and I called it keys down, not input. Keys down. Okay. And all I'm going to do is I'm going to look at the keys down. I'm going to say, well, is left pressed? So left is pressed if this is 0. So remember, this is now in the top nibble. So now this 1 is actually 5. So if bit 5 is 0. So I don't remember the bit instruction. Yes. Maybe even having some constants for this would be nice. And if neither are pressed, we're just going to stop the paddle. So stopping the paddle is easy. We're just going to, we just set the velocity to 0. Easy. And similarly, these two are pretty easy too. And yeah, we could do something to reduce code duplication here. But right now, not important at all. So let's start with moving right. I'd say like maybe a good velocity for moving right is 1.5 pixels. So again, we're gonna set this to velocity to 1.5. And then for moving left, we need to do the same thing, but negate it, minus 1.5 pixels. So that is going to be let me see here. If we said this was 180, except I want to be in hex mode. If we said this was 180, then we're dealing with what? A word. Gotcha, okay. 0 minus 180. No. Equals. Yeah, so is that right? That looks wrong to me. I don't like that. I'm just going to do this by hand. But then we add 1 to it. Yeah, okay, there we go. FE180, it's FE80. Huh. Okay. So I am surprised. But there we go. Okay, and then the only other thing we have to do is we need to, this is actually going to be like handle input actually, and then update paddle is going to call handle input, and then it's going to call, you know, update paddle X. It's going to actually have a procedure to do the movement, and that update paddle X is going to look an awful lot like update ball X, except simpler. Maybe. We do actually still need to have collision detection on the left and the right, so maybe it's not. And because they're so similar, maybe there's a case for, you know, we should start refactoring this a little bit or something. I mean, we don't negate velocity. We don't have to do that. That should just be okay. I don't know. Oh, I need to define my constants. Might as well leave them all right now. Up is and line 308. line 358. And we've got it. We're done. Okay. Reload the ROM. Let's see how this goes. It's not working. We're missing something. It's not working. Okay, that's fine though. Do we call handle, or do we call everything we need to call? Update input? Do we call update input? We do. So we are calling update input. We are loading C with the appropriate number. Oh, so we do have, I do have some kind of input going on here, but it's not what I want. So let's see here. What are we doing wrong? We read directions. Do I have this backwards? I might have this backwards. Yes, I put the buttons on the top, not the directions on the top. So this is annoying, but I have to swap these around. But I'm just going to do that. I'm also actually not sure that I did this completely right, because I think this probably doesn't matter too much, but I do want to make sure that I clear out. I don't actually know if you ever end up reading anything but from there, but I want to make sure that I clean those out so that they don't accidentally step on each other. So that should be better. Fingers crossed. Oh yeah, there we go. And the collision on the left is correct. We might want to actually adjust even more. Collision on the right isn't accounting for the width of the paddle, so let me fix that. Right, so we want to go back 8 pixels, 152, 151. Look at that. We got motion. We got motion. We got a ball bouncing. We got a paddle moving. We're barely touching the Game Boy CPU. The Game Boy CPU is like super chill, which is great. Yeah, you know, this is a little bit early because I wanted to try to do about 90 minutes every day, but I actually think I'm going to stop here rather than try to get started with something new. So I think the next obvious thing to do is probably to get the ball bouncing off of the paddle. That may be tricky. There's a good chance that there's going to be some trial and error involved in that. So rather than continuing to work on this today, I think I'm going to call it early, declare this a great success, and then today's Friday. So then I guess on Monday we will try to get the ball bouncing off the paddle. Yeah. Thank you for watching. If you're watching right now, I'm going to post this on YouTube. The link is in my channel description below. That's also a way to catch up on what I did yesterday if you want to see that. Or to keep up to date if you happen to miss a day. On Sunday, I stream the New York Times Sunday Crossword at 6 p.m. Pacific time. So if you want to watch that, I know it's very different from programming Game Boy games, but that is something I like to do. So, you know, if you're so inclined, please watch that. Otherwise, I suppose I'll see you on Monday. Yeah, take care. Thanks for watching.